Hi friends, இந்த வீடியோவில் என்ன பார்க்க போகிறோம்னா பவர் சிஸ்டம்னா ரிமைனிங் இருக்கிற லோட் ஃப்ளோ அண்ட் ஃபால்ட் அனாலிசிஸ். ஓகேங்களா, லோட் ஃப்ளோ அனாலிசிஸ் அண்ட் ஃபால்ட் அனாலிசிஸ் பார்க்கலாம். இதுக்கு முன்னாடி நேற்று பார்த்ததில் ஒரு சின்ன கரெக்ஷனுங்க. என்ன அப்படின்னா, கரோனா எக்ஸ்பிளைன் பண்ணியிருந்தாங்களா, அந்த கரோனா எக்ஸ்பிளைன் பண்ணியிருந்ததில் ஏர் டென்சிட்டி ஃபேக்டர் வேல்யூ சேஞ்ச் ஆகிருக்கு. நான் இதை பார்க்கல. ஸோ ஓகேங்களா, சரியாக கவனிக்கல. அது ஐம் சாரி ஃபார் தட். Del is equal to 3.92 into barometric pressure divided by 273 plus T. ஓகேங்களா, ஓகே. தென் அதே மாதிரி கிரிட்டிக்கல் டிஸ்ட்ரப்டிவ் வோல்டேஜில் M0 is irregularity factor. ஓகேங்களா, irregularity factor. It is not roughness factor, it is irregularity factor. ஓகேங்களா, for smooth conductors value will be 1 and 0.8 to 0.92 for dirty conductors. And then M0 value, that is 0.87 to 0.8 for standard conductors. ஓகேங்களா, standard conductors. Then இதில் visual critical disruptive voltageல MV is roughness factor. ஓகேங்களா, roughness factorம் irregularity factorம் சேஞ்ச் ஆயிருச்சு. ஓகேங்களா, சாரி ஃபார் தட். இதை எனக்கு இன்டிமேட் பண்ண, என்னோட தவறை எனக்கு உணர்த்தின மை டியர் சிஸ்டர் கிருபா Telephone-க்கு thanks. Load flow and fault analysis. Okay, load flow or power flow solution is the determination of current, voltage, active power and reactive voltage ampere at various point in a power system operating under normal steady state or static conditions. Short circuit occur in power system due to various reasons like equipment failure, lightning strikes, fall of branches or trees on the transmission line, switching surges, insulation failure and other electrical or mechanical causes. All these are collectively called faults. Okay, in power system la என்ன types of faults இருக்கு, என்னென்ன அனாலிசிஸ் பண்ணுறாங்க அப்படிங்கிறது பார்க்கலாம். ஓகேங்களா, பஸ் கிளாசிஃபிகேஷன். பஸ்ஸு ரொம்ப இம்பார்ட்டன்ட். தட் இஸ் லோட் பஸ். PQ பஸ் இஸ் கால்டு லோட் பஸ். ஓகே, ஞாபகம் வச்சுங்க, லோட் பஸ் ஆர் PQ பஸ். ஸ்பெசிஃபைடு வேல்யூஸ் ஆர் PQ, unspecified values are determinant V, del. Okay, V, del is the determinant value. Generator bus, PV bus. Generator bus, PV bus. PV, power voltage bus is the generator bus or voltage controlled bus. Variables are PV specified variables. Unspecified variables are Q and del. Static bus or reference bus or swing bus, that is specified values are minus determinant V, del and unspecified variables are PQ. Okay, where determinant V is the magnitude of voltage, del is the phase angle of the voltage and P is the active power and Q is the reactive volt ampere. Okay, இந்த டேபிள் ஞாபகம் வச்சுங்க. இதிலிருந்து கூட 1 மார்க் கொஸ்டின் கண்டிப்பாக வரலாம். ஓகேங்களா, ஓகே. Bus admittance matrix, Y bus matrix. Consider a power system network consisting of 2 generating stations, which is shown figure, single line diagram of simple power network. Okay, for this the bus admittance matrix Y bus related to bus voltage V bus and bus current I bus through the relation I bus equal to Y bus into V bus. Okay, then the system impedance diagram is shown below. That is Z11 is equal to J into xg1 plus xd1. Z22 is equal to J xg2 plus xd2. Okay, that is my values are given for impedance diagram of the power system network. Okay, then equivalent admittance diagram of the impedance is shown in second figure. Okay, these equations can be written in matrix form. That is I is equal to YV. I is equal to YV formula we can write in the matrix form. Okay, the compact form of these equation can be written as IP is equal to epsilon, that is Q1 to N, summation of Q is equal to 1 to N YPQ VQ. YPQ VQ. Okay, then bus impedance matrix, that is Z bus. Bus impedance matrix Z bus is the inverse matrix of Y bus. Y bus oda inverse is the Z bus. Okay, and admittance matrix Y bus Z bus is equal to Y bus inverse of Y bus, and the relation between Z bus and V bus is as follows, that is V bus is equal to Z bus into I bus. V bus is equal to Z bus into I bus, that is V is equal to Z into I, and the formula we can write in the matrix form. Okay, development of load flow equation, that is for n bus system the nodal current equation is IP is equal to summation of Q is equal to 1 to n YPQ VQ. YPQ VQ. Okay, VP star IP equal to PP minus JQP, that is P is the active power, Q is the reactive power, IP is the PP minus JQP. VP star is the conjugate value for that. Okay, substituting that is IP in equation 3, so we will get VP is equal to 1 by YPP into PP minus JQP by VP star minus summation Q is equal to 1 to n YPQ VQ. IP has been substituted by the real and reactive powers because normally in a power system these quantities are specified. Okay, then symmetrical components. A three-phase system is said to be symmetrical when the system viewed from any phase is similar. Thus in a three-phase symmetrical system, the self-impedance of all the three phases are equal and the mutual impedance, if any, between three phases are the same. Okay, then any three-phase system having unbalanced phasor quantities can be represented in terms of three-phase balanced phasor components as a combination of positive, negative and zero sequence components, which are as follows, that is VA is equal to VA0 plus VA1 plus VA2, VB is equal to VB0 plus VB1 plus VB2, like that. Okay, positive phase sequence components. First, positive phase sequence components, it represents a set of balanced phasor VA1, VB1 and VC1 that is shown in the figure. Okay, original phasor and positive sequence phasors are represented in the diagram format. Okay, these components have three phasors equal in magnitude displaced by 120 degree and having same phase sequence as original phasor. Okay, negative phase sequence components. These components have three phasors equal in magnitude displaced by 120 degree but having phase sequence opposite to original phasors. It represents a set of balanced phasor, that is VA2, VB2, VC2. Okay, original phasor lende displacement irukungla 120 degree displacement. Okay, zero sequence, these phasors are equal in magnitude and having zero phase displacement set of VA0, VB0, VC0. Okay, alpha operates E power plus J 120, that is equal to 0.5 plus J 0.866. Alpha squared will be minus 0.5 minus J 0.866. Alpha cube will be 1. Okay, alpha for 4 will be alpha, that is alpha க்கு பதிலா நீங்க I நீங்க படிச்சிருப்பீங்க முன்னாடி. ஓகேங்களா, I power 4 equal to I. So 1 plus alpha squared is equal to 0. Okay, so V is equal to matrix into VA0 or IA is equal to matrix into IA0 IA1. Okay, then we will get the zero positive negative components, that is VA0 is equal to 1 by 3 into VA plus VB plus VC. VA1 is equal to 1 by 3 into VA plus alpha VB plus alpha VC. VA2 is equal to 1 by 3 into VA plus alpha squared VB plus alpha VC. In matrix formula we can get like this: VA0, VA1, VA3 0 positive negative components equal to 1 by 3 into 1 1 1 matrix, and VAB VBC or IA value will get like this. Okay. Then move on to three-phase power in terms of symmetrical components. That is SABC equal to 3 VA0 IA0 star plus VA1 IA star plus 3 VA2 IA2. Sum of symmetrical components power equal to SABC. Okay. Then power value, that is 3 into VI cos phi plus VI cos phi, VI cos phi 0 plus VI cos phi 1 plus VI cos phi 2. Okay, 0 sequence, positive, negative sequence. Okay, sequence impedance, then move on to sequence impedance. The positive sequence impedance of an equipment is the impedance offered by the equipment to the flow of positive sequence current. Similarly, the negative sequence or zero sequence impedance of the equipment is the impedance offered by the equipment to the flow of corresponding sequence current. Okay. Sequence impedance of a transmission line: positive sequence impedance, that is Z1 is equal to Zs minus Zm. Negative sequence impedance, that is Z2 is equal to Zs minus Zm. Zero sequence Z0 is equal to Zs plus 2Zm plus 3Zn. Zs is the self impedance or per phase. Zm is the mutual impedance between two phases. Then sequence impedance of synchronous machine. Okay, synchronous machine order sequence impedance: positive sequence Z1, depending on time interval of interest, one of the three reactants may be used. Okay, Z1 Z2, we will get Z1 JXD, then Z2 J into XD double dash plus XQ double dash by 2. That is negative sequence impedance. Zero sequence impedance, that is zero sequence current are all in phase and therefore do not produce any rotating field. Okay, the zero sequence impedance Z0 depends upon the type of grounding and the zero sequence impedance per phase of the generator. Okay, sentence ஞாபகம் வச்சுக்கங்க. ஓகேங்களா, each sentence are important because இது hint notes, it's not a notes. Okay, sequence network equation, sequence network of unbalanced alternator, positive sequence network unbalanced alternator, EB Z1 EC Z1. Okay, EA Z1, Z1 will be positive sequence. VA1 equal to EA minus Z1 IA, Z1 into IA1. Okay, then negative sequence network, that is so Z1 Z2 Z1 Z2 IA2 IB2 IC2, negative sequence network of synchronous machine. That is VA2 is equal to minus Z2 IA2. Zero sequence, that is even here, then IN is equal to IA0 plus IB0 plus IC0 equal to 3 IA0. Z0 is equal to 3 Zn plus Z0G. Okay, VA0 is equal to minus Z0 IA0. Then move on to fault analysis. Fault may occur at different points in power system. Fault that occur on a power system are broadly classified as follows. That is symmetrical fault analysis. First of all, symmetrical fault analysis. In such type of faults, all the three phases are short circuited to each other and often to earth also. Okay, such faults are balanced and symmetrical in the sense that the system remains balanced even after the fault. That is transient on a transmission line. When a sudden change in voltage and current distribution takes place, power energy distribution also changes. But energy redistribution is not instantaneous, but it takes time. Okay, this change in energy distribution is called transient phenomenon in power system. Okay, sudden change நடக்கிறதா transients. Okay, transients நீங்கள் சர்க்யூட்ஸில் பார்த்துருப்பீங்க. Okay, same like that. The current after short circuit IT has two components, that is I is equal to IS plus IT, that is short circuit current plus transient current. Sorry, that is transient current plus steady state value of current. Is is the steady state value of current, it is the transient current. I is equal to Vm by Z into sine omega t plus 5 minus theta minus Vm by Z into sine of 5 minus theta into e power minus r by L into t. It is steady state component of current, and second one is the transient components. Okay. I is equal to steady state value, that is I is equal to Vm by Z into sine of omega t minus 5 minus theta. It, that is transient current, will be minus Vm by Z into sine of 5 minus theta into e power minus r by L into t. Okay. 3-phase sudden short circuit of an unloaded alternator எப்படி இருக்கும் அப்படின்னா, whenever a 3-phase short circuit occur at the terminal of an alternator, the armature current suddenly increases to a large value and voltage across its terminal drops. Voltage across its terminal drops. ஓகேங்களா? இதெல்லாம் வந்து 1 மார்க் கொஸ்டின்ஸ்க்கு ஹிண்ட் மாதிரி தான். இந்த மாதிரி பாயிண்ட்ஸ் வச்சு தான் நம்மளுக்கு 1 மார்க் கொஸ்டின்ஸ் ஃப்ரேம் பண்ணுவாங்க. ஓகேங்களா? தென் subtransient faults, that is IF double dash is equal to VT by XD double dash. Then move on to 3-phase fault. 3-phase fault diagrams are given. Then 3-phase fault IA1 is equal to EA by Z1. Okay, these are all the key points. Please make it note and clear with these points. Okay, positive sequence currents are present in all type of faults. Okay, positive sequence currents are present in all type of faults. Then negative sequence current are present in all unsymmetrical faults. Okay, negative sequence current are present in all unsymmetrical faults. Zero sequence currents are present when the neutral of the system is grounded and the fault also involves the ground, and the magnitude of the neutral current IN is equal to 3 IA0. Okay. Then voltage of neutral Vn is equal to minus IN Zn, that is equal to minus 3 IA0 Zn. Shunt faults are characterized by increasing in current and fall in voltage and frequency. Fall in voltage and frequency. Whereas series faults are characterized by increase in voltage and frequency and fall in current. Okay, series faults வந்து என்னென்ன நடக்கும் அப்படின்னா, that is voltage increase ஆகும், then frequency increase ஆகும், then fall in current in the faulted phase. Okay. These are about fault analysis and power flow analysis. Okay friends, thank you.